record. There we go. All right. Now we're cooking with gas. So at the end of class, I'll post these notes as well. So, you know, if you're kind of a visual learner, then you can just sit back, relax, enjoy the show, and then just know that whatever I write, I'll put them on Moodle after class, okay? And so this is not in the textbook. And so we used to do it at the end of the course, but like I was saying last day, by the end of the course, you'll have seen this in all your other classes. So then it's not as flashy as I want it to be. And so then I'm going to start with this and beat everyone to the punch, hopefully. Okay. It's math. So it's my domain. I get to cover it first. Oh yeah, so what I was saying here, so what I did was I'd go in. This is just for me. This isn't for you to decipher. But like I said, I kind of stopped paying attention to the Wednesday because look at how blocked it is, right? Everyone has all these different schedules. And I know what you're thinking, well, Emily, isn't there a system that knows all these things? Yes. Do they give me access to it? No. So, so I have to do it myself. That's okay. I don't mind. Like I said, there's not a lot I wouldn't do. But this is one of the options that I need to go back and kind of look at to see if it's actually open for everyone or if I just kind of gapped out kind of in the middle. Anyways, but pretty quickly it became kind of obvious that, you know, I think there's something here for people and then kind of everything else kind of blocked up pretty quickly. And so then the other option is this whole chunk. I'm pretty sure. Human error and all. So there's a possibility. But we've got a couple of options. And so what I'm going to do is just go back and double check this one. And then I'll post an official poll on Moodle because it has to be everyone in favor of a change in order for us to make that change. But then we'll be able to do that hopefully. So, so I'll post a poll on Moodle for you to do this week. I guess we'll keep it kind of status quo with the Friday block, but I'll kind of give you the exercises. They're all in that handout, which is kind of hefty, I think, or at least for me. But if you can work through those problems, then you're done for the week. Okay, so keep an eye out for that poll that I'll post on Moodle, making it more official, I guess, covering my behind. Okay, so numeration systems, things about numbers and counting that you probably have never paid attention to before, like truly sat down, you understand it, right? If I have, I don't know, hey, look at these props. I have all these cards, right? I'm not going to count them in front of you, but ha ha. Make it rain with these cards, right? You have to count them in your head. You start with 1, 2, 3, 4, 5, 6, 7, 8, 9. And then what happens when you hit 10? We're going to go, okay, now we only work with 10 symbols. Okay, so digits, because we have 10 fingers. And so then we say, well, how about once we have groups of 10, we could just lump them into one group and move them over one, right? And that's why it becomes 1, 0. a group of tens followed by 0 individual thingies. I guess I didn't need these cards. It's fun to have props though. Maybe I'll keep them handy. Haha, digits. So it all comes from, we have 10 digits, Latin. So 10 fingers or digits. Ugh. Okay. So those are the symbols that we typically work with. Okay. There are things like Babylonian math. They worked in base 60, I want to say, which is kind of crazy. So we work in base 10. And so we're grouping by tens. Okay. And so then what happens is we've got these 10 symbols that we use, and then when we hit a larger number, right, we express it in terms of powers of 10. Okay. And so, well, 10 is 10 to the power of 1. What's 10 to the power of 0? Let's start there. 10 to the power of 0 is 1, right? So technically still working in powers of 10, but we don't say it like that, right? Anything to the power of 0 is 1. Okay? And so then 10 to the power of 1 is of course 10, and 10 to the power of 2 bumps us up. And so that 1, I guess, is positional, right? 1 0 is different from 1 0 0. Right? Okay. Some of these notes are obviously kind of cryptic. Whoa. Hello. Cryptic. Oh, it doesn't work that way, I guess. But that would be funny if you could train it to do something with the word. And it's only because I'm trying to not write so much. And so, because my hand just refuses to recover. And so sometimes I'm just kind of jotting down the gist of it, and then we'll fill in the notes as we go. A lot of it is examples, right, that we'll work through either on our own or together. Okay? And so sometimes I'll try to make them make more sense as a standalone document. I was just kind of being lazy. Okay. So like we said, this 1 in 10 is positional. And so instead of kind of continuously making up new symbols or new values to work with, we just know that 10 means 1 group of 10 items. That's really sloppy. I should have tacked up some boxes or something nicer to read. Okay. And is it 10? 1, 2, 3, 4, 5, 6, 7, 8. It is. It's not really an example, I guess, but 32, if you had to think about 32, 32 is 3 groups of 10 and then 2 extra. Okay. And so let's skip to here as another example. What if we had to explain what 134 means? 134 means 1 group. Well, let's start with 100, but then what we're going to do is we're going to move it to powers of 10, right? 100 being 10 to the power of 2. And so really, it's going to be 1 group of 100 or 10 to the power of 2. Right? Then, or I guess, and 3 groups of 10 or 10 to the 1 and then 4 singles, or let's call them extras. And I'll do this in pink because we might not be used to seeing it, right? Of thinking of ones as 10 to the power of 0. Yeah. So what we can do instead of using words, because we don't like to use words so much, is we can write this in expanded form. And so here, we can use this to write in expanded form. What's that going to look like? Maybe I'll try to make my, oh, it's been a while since. There's been updates in Notability since I last used it, I think. Let's see here. I usually like to write with a thick pencil, but then I write really hard, hence the wrist problems. I just can't seem to take it. So when I have a thin pencil, I don't really like the look of it, but here we go. And it's kind of hard to see. You see that in the back? Yeah. Super eyes. What we can do is we can say, okay, that's 1 times 10 to the power of 2 plus 3 times 10 to the power of 1 plus 4 times 10 to the power of 0. That's going to be called expanded form, which we're going to be using to move between these bases. Okay. So far we're still working in base 10, but in computer science, you use base 2 a lot, binary, of course. Use octal sometimes, and hexadecimal quite a bit. Okay. So what if we have to write 52,613 in expanded form? All right. Let you give it a go here. I'll start by writing it out kind of loftier. I don't like this pencil like that. If you write it out kind of, to write it in expanded form, write it in expanded form. The reason I do that is because it makes it easier to write my 10 to the power of 0 underneath. That's just a reminder to myself. You don't have to do that, right? But we're just starting out. We're just writing these things for the first time. And so let's just remind ourselves, right? And this part's easy. What am I doing? 10 to the power of 0 for the first one, 10 to the power of 1, 2, 3, 4, 5, 6, 7, 8, right? You can just keep going. And it's kind of just more methodical that way. Okay. But like I said, if you can just look at this thing and do it, that's neat. I can't really, or I can't be bothered rather. And so I like it when it's methodical. Okay. And so what do we have? Well, now it's just tedious, right? How do we write this out? I'm going to write 5 times 10 to the power of 4 plus 2 times 10 to the power of 3 plus 6 times 10 to the power of 2, right? And I'll get to work here. And I like to see brackets around these, right? You'll you'll know the importance of brackets, missing brackets. What a mess, right? And so just like computer science, in math, you can never have too many brackets. Just bracket it all out. So 5 times 10 to the 4 plus 2 times 10 to the 3 plus 6 times 10 to the 2 plus 1, oops, plus times 10 to the 1 plus 3 times 10 to the 0. Ta-da! Expanded form. Can we zip it back up? Sure thing. What if we had to write from this expanded form back into decimal form? Right? Now, for this one, right, I'll give you a moment to think about it. Well, how can you tackle this? Your highest power of 10 is 8, 10 to the 8. And then you've got a 7, but then notice how there's nothing for 6 and 5, but then at 4, what happens then? You're gonna have zeros, right? We don't typically expand the zeros. There's no harm in doing that. It just makes it really long, right? And this is, I wrote it like this to showcase that you can just skip the zeros if you want to. Okay. So what I usually do is I make little slots, right? I have my 10 to the 8 is my biggest slot. And this is what I mean by slots. 1, 8, 7, 6, 5, 4, 3, 2, 1, 0. So here, this is my 10 to the 8, 10 to the 7, 10 to the 6, 5, 4, 3, 2, 1, 0. Now, what can I do? I can just kind of drag and drop the ones that I want into their appropriate slots and then fill the rest of them with zeros. Let's go orange. Orange, you glad I didn't pick pink? We'll deal with that single first. 3 times 10 to the 1. And then 6 times 10 to the 4. 9 times 10 to the 7. And 4 times 10 to the 8. I'm going to fill the rest of these with zeros. So then I get 4, 9, 0, 0, 6, 0, 0, 3, 7. Oop. Questions so far? Yeah. Oh, because if it's not written here, I'll do this. 0 times 10 to the 6 would go kind of in here. Right. So if there's nothing multiplied by that power mentioned, then it's going to be a 0. Makes sense? Any other questions? What about decimals? Uh-oh. Decimal points. See, aren't these things that you have never thought about, had to think about probably before? Numbers. So a decimal point separates whole values from fractional values, but they behave the same way. So what happens when you're kind of on one side of a decimal point here? And again, I'm going to work with my slots. Yeah. Here I have 10 to the 0, 10 to the 1, oops, 12, nope, 10 to the 2, 10 to the 3, blah, 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 blah. I can keep going. On the other side of the decimal, what happens? Well, 1/10 is 10 to the negative 1, right? 1/10 is 10 to the negative 1. And so after 0 on the other side of the decimal, what's going to happen is now you have 10 to the negative 1. Hundredths is going to be 10 to the negative 2. Thousandths, 10 to the negative 3, and so on and so forth. Because I don't know what it would be called after that, so I'll quit there. Thousandths, 10,000ths, I guess. And I'll just make a note here, right? Because 1/100 is 10 to the negative 2, for example. So we can work across the decimal, right? And we can still write things in expanded notation. What if we had to write 479.352 in expanded notation? I'll be using my slots again. You don't have to, you can just skip right to it if you want. I like to start around the decimal. Otherwise, if I'm trying to kind of count out, it's tempting to make this 10 to the power of 3, but then you've forgotten that you start at 10 to the 0, right? So 10 to the 1 here, 10 to the 2. That's not expanded notation, is it? It's how I get there, right? One way to get there, but the answer would be 4 times 10 to the 2 plus 7 times 10 to the 1 plus 9 times 10 to the 0 plus 3 times 10 to the negative 1 plus 5 times 10 to the negative 2. But this is where I can cheat and just bump these over. 2 times 10 to the negative 3. So that's the expanded notation. Any questions so far? So as I mentioned, there are different numeration systems that we use for different purposes. And so we are most commonly grouping in tens, right? Base 10. That's what we're used to working with, right? But there are rules that we'll talk about for base 2, base 8, and base 16 hexadecimal. And so those are the ones we'll focus on, but I want to introduce any base and ace of base. No. Well, maybe. How can I incorporate ace of base into a change of base question? That's a good assignment. So I'll show you how to move around between any base. Yeah. And so here, these were supposed to be kind of big boxes. They're just tiny little dots. But if you feel like doodling, you can make them bigger, I guess. But it's also outlined in the image below, so. Let's start with base 2. So we have, well, how many things do we have? One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, base 10. So I guess let's not start at the top. Let's start at the bottom. So in base 10, what we're used to doing is we say, okay, any groups of 10 that come my way, I'm going to lump them all together. Right? Question? And then we have one, I think that's what it was. One group of 10 followed by one extra, right, of 10 to the power of 0. If we work in base 9, right, then we only have 9 digits as opposed to 10, or I guess 9 symbols, I should call them, because digits are 10s. But that's me being super picky. Okay, so now we have 9 symbols that we can use. And so that means once we hit 8, then we bump it up, right, into one lump. Okay. And so what happens is now in base 9, this group of 8 fills the first decimal, or the first place, right? We have one group of 8 followed by 2 singles, base 9. Okay. And then everything kind of works out. Let's talk about base 8. Kind of zoom in here a little bit, because that's octal, right? Octal is base 8. And so again, we only have 8 symbols. So as soon as we get to 7, then we bump it up, right? And so here we've got a group of 7 things and then 3 extras. Or sorry, 8 things, 3 extras. Good. Okay. And then it moves on. Want to jump to 5 because this is where it gets a little bit weird. Right. And so here I've got my first group, of 5. And then my second group of 5. So now I have 2 groups of 5, right? And then 1 single. And so, and we know that, looking at 11 cards, let's say, right? You would say, oh, I can make 2 groups of 5 and one single. Okay? And so that's how it works. How could you get to this kind of the next step? What would you need? You would need to have 5 groups of 5 to be able to go to that next step, right? And then you would have 1 group of 5 to the power of 2. Right? And so here, right, same thing for 3 or 4, but let's go to 3 because it's more interesting, because that's what I was just saying, right? If we're working in base 3, now I'm making groups of 3, kind of starting off lumping groups of 3, and then I take a step back and I see, hey, I can make another group of 3 of 3s, right? Not just 3 to the power of 1, but 3 to the power of 2, right? So I can make one group of 3 to the power of 2 or 9. And so that's why we have one group of 3 to the power of 2, 0 groups of 3 to the power of 1, right? Because there are no loose 3 to the power of 1s. And this is what kind of trips me up a little bit, is because I look at this and I say, well, actually I have 3 groups of 3, but they're already moved over, right? They've kind of graduated, so they don't count. Puns. And then 2 singles, right? 2 singles, 3 to the power of 0. Okay. So now, base 2, we only have 2 symbols, 0, 1, right? And so now you start off and you make your groups of 2, then you take a step back and you say, well, I can make another group of 2. And here's another group of 2, 2 groups of 2, right? And then I have 2 groups of 2 to the power of 2. I think 2 to the power of, I lost it. 1. Anyways, I'm gonna have one group of 2 to the power of 3. 2 to the power of 3 is what? 8, right? So I have one group of 8. I have 0 groups of 2 to the power of 2, right? I don't have any groups of 4. I did. But then I lumped them into the 8s. But I do have one loose group of 2 and then one single. How comfortable are you guys with binary at this point? Top notch. Got one row of top notch. Thumbs up, A-okay. Just one row though. Don't let them stress you out. Okay. So, what did I want to say? I kind of lost, I went rogue on my notes rather. Let's see here. Sure. Let's do this. It doesn't hurt to do it again, I think. So in base 2, oops, because I can say it and I can talk about it. I can talk about a lot of things. But if we were to work this in base 2, how's this going to work? Right. First, I'm going to start off and I'm going to make groups of 2. 1, 2, 3, 4, 5. So what I can do, because I already know that this little guy hasn't, well, maybe let's make the groupings again. We'll finish all the groupings. So what are we gonna do here? So I made groups of 2. Looks like I can still kind of consolidate more groups of 2, but now each of these is one thing, right? They've already been grouped. And so now I can make a group of 2, and it looks like I can make another group of 2. Those colors are way too similar, aren't they? Let me make them blue. Good, not great. Anyways. Blue. I tried, because now I'm gonna go pink, I guess. And just pop these down. Now I look back and I say, well, actually I can make another group of 2 here, right? Leaving no blue ones, no light blue ones to be had. If we think about our slots again, the slots 10 to the 0. Oops, sorry. Haha. What changes? We're not working in base 10 anymore. We're working in base 2, but we do the same thing. 2 to the power of 0, even though I tried to 2 to the power of 0, 2 to the power of 1, 2 to the power of 3. Nope. 0, 1, 3. Not usually. 2. 2 to the power of 3. 0, 1, 2, 3. This is why I have to work methodically, because otherwise, even when I am working methodically, I skip stuff. So what's this going to look like? Well, I have the one single, right, in dark blue that I'll keep in dark blue. And then I have the one group of 2 to the power of 1, so 2 all alone. Oops. Here. And then I managed to squirrel away my groups in light blue, right, into the bigger group of 2 to the power of 3. So that makes, I have 0 here. Right. And then finally, I have one group of 2 to the power of 3. And so what this becomes is it becomes 1, 0, 1, 1 base 2. I tend to write the word because otherwise on a test or something like that, if I just use the number, it can be kind of confusing because you could accidentally read it as just a number, right? And I don't want that to happen. So I do write it in words. You don't have to, but it might be a good thing to do for when you're reading through your notes again. Let's talk about any base B system. We need to have B symbols, right? And so I don't think I meant to have that much space there. I didn't. There's nothing I wanted to write there. Just waste of paper. Could write something fun. I'm not going to. I feel like I'm constantly adjusting the spacing in these, which is why I usually don't like to do kind of fill in the blank notes, because I can have, that's so hard to figure out how much space you need. But in this course, it kind of works. So there are a couple of different methods that we're going to talk about. Now, a lot of these are kind of, I'm taking the mathy approach, which is usually the longer approach. I'll show you how to use my calculator, and I encourage you to figure out how to use your calculator to move between bases. But you'll also have to do it on a test, and so it might be nice to know how it works so you can do it. Okay. So to change from base B, so any base B, to base 10, you're going to write the numbers in expanded notation. And then the resulting number is in base 10. Okay. We can, maybe that's what we'll do. What if you had to write this out in expanded notation? Haha, I figured out a use for that space, but I'm adding it now. Write the above in expanded notation. You have 1 times 2 to the power of 3 plus 0 times 2 to the power of 2 plus 1 times 2 to the power of 1 plus 1 times 2 to the power of 0. This is 1 times 8, right? Plus, if you want to take it and think about it, was 0 times 4, 1 times 2 plus 1 times 1. 8. Phew, had the answer, but I got stumped on the 1 times 2. Probably shouldn't have said that. 8 plus 0 plus 2 plus 1 is 11, which is what we knew. Right. So moving from any base to base 10, you are going to write it out in expanded notation and then just do the math, right? Use a calculator, whatever. And it'll just be in base 10. These little blurbs are kind of unassuming, I guess. Like I said, I'm just writing things down so I don't have to write them out. But I'll try to highlight them, the ones that you're going to use, right? Because these are the tools that we're building today. All right, so there is a couple of examples. Bless you. We'll do the first one. It's the same series of numbers, just in base 2, 4, and 5. So what I'll do is we'll do the first one together, and then I'll leave you to do the other 2, but in the notes I'll post the solutions, right? So if you wanted to do them later, you can. Yeah? But let's do this one. So, all right, converting from any base to base 10, what am I going to do? I'm going to write it out in expanded notation. And for me, I find it really helpful if I also write these little guys out in kind of lofty notation, because then I can kind of do my slots as well. This is base 2, right? And we can start on the whole number side of the decimal, right? 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3. And then of course, I don't know what the fraction of 2 halves, quarters, eighths. 2 to the negative 1, 2 to the negative 2. Luckily, I don't have to think about it. This is just a tool to get me to the expanded notation, right? And I'm using the expanded notation to then get to base 10. And maybe I'll give myself a bit more room here. 1 times 2 to the 3 plus 0 times 2 to the 2 plus 1 times 2 to the 1 plus 1 times 2 to the 0 plus 0 times 2 to the negative 1 plus 1 times 2 to the negative 2. This becomes 1 times 8 is 8, 0 times 4 is 0, 1 times 2 tends to be 2, 1 times 1 is 1, 0 times 2 to the negative 1 is 0, and 1 times 2 to the negative 2 is 0.25, right, 1 over 4. Putting me at 11.25, 9, 10, 11.25 base 10. Yeah. 2 to the negative 2. So here, if you try it on your calculator, where's my calculator? Here, ready. Lock and load. 2 to the power of negative 2 is 1 over 4, and that's 0.25. Do you guys know how to do, make sure you know how to do powers on your calculator, right? Because they're not always going to be this breezy. And I don't expect you to just know it. It's crazy. So I did my undergrad in math, and then my master's is in stats. And so whenever anyone found out, oh, you're studying math. Oh, quick, what's 49 times 63? I have no clue, and none of the patience to do that, because that is not what math is. So I don't do math in my head. And at this point, it's just kind of, I refuse to do it. Too cool to do it. But so what I'm gonna do is I'll put a little star here, and I'll say here, complete at the end of class. Oops. Or on your own. That's fine too. Just make sure you work through them. I'll post the solutions. They'll be part of the notes that I post. Right, so I'll finish them off before I post them. But let's do that for those two. All right, give it a go. See how it is. We already looked at how can we move from base 10 to base B, right? We added that image where we grouped 11 things into different bases. And so we've already seen that if you want to move into base 2, you group by 2s, base 3, group by 3s, etc. And so just in general, there are kind of I say common in the math world. Can also use your calculator. Let's add that in here. Or 0. Use your calculator function. That's probably the most common. Or like an online calculator or something like that, right? But here we're in the business of introducing things, concepts, ideas. So we're not gonna do that so much, but I want to show you how to do it using a list or a table of powers in base B. I don't really use that so much because it requires tables and listing a lot of things that you don't end up needing. I tend to use repeated division. There are lots of other cool ways to do it. But like I said, I like to kind of be methodical, and sometimes that's not the most efficient way to do it. But at least if I'm able to apply the same method each time, then that's what I prioritize. And so that's what I'm going to do. But I encourage you to look into other ways of moving between bases. There are some really cool ones, but I'm kind of old school. Okay. So I'm going to focus on the repeated division, because what could we do? We could use a table like this. And I guess in theory, I kind of am using a table like this by trial and error. I'm kind of generating a portion of this table. Okay. And so what's it doing? If we're working in base 2, then I need to know what my groups are, right? 2 to the power of 0 is 1, 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8, 2 to the power of 4 is 16. We haven't gone that far, right? But you can imagine, right? Now you've got 2 groups of 8, lump them into 116. Take it one step further, 2 to the power of 5, 32, right? And so now these are your groupings instead of zeros, tens, hundreds, thousands, 10,000s, right? Now you've got this very fancy 1, 2, 4, 8, 16, 32, just rolls off the tongue. And so what would you do? You'd work through maybe your cubes. Usually we don't have cubes, and that's where the repeated division comes in. Okay. And so let's see here. Let me show you how I do it. First, we can use the table version, but I prefer the repeated division, just kind of warning you. But I'll introduce the table. So what we want to do here, we want to convert 42 to base 2. And so I have this table of base 2 that I can steal conveniently here. Copy. I'll zoom in. So what am I going to do? I'm going to keep going with this table here. This table, 2 to the power of 6, I have is 64. So what I'm going to try to do is group as many of these 42 into groups of 2, 2, 2, 2, 2, but I max out somewhere between 32 and 64. Right? And so that kind of gives me my cap, right? 42 would go somewhere here. Oops, that doesn't look like 42, does it? Somewhere between 32 and 64. Gonna ignore the 64 now. All right. And I'm gonna say, okay, 42 is gonna be 1 times 2 to the 5. All right. I can extract 32 of those 42. And I can just leave it as 10 for a little bit. All right. So here, this is 32 plus 10 is still 42. That's true, right? And so now what I can do is break it break it down. Break this down more. Okay. So then what can I do? Well, 10 doesn't go between 16 and 32, right? It does go between 8 and 16, but what happens with my 10 to the power of 4? I'm gonna have to have a 0 times, sorry, 2 to the power of 4. I said 10. Confusing. So this is gonna be 1 times 2 to the 5 plus 0 times 2 to the 4 plus 1 times 2 to the 3 . I can do that, and then I could go plus 2 if you want. But we're going to continue breaking that down. All right. Break down more. All right, I'm going to be lazy and just copy pasta this. Hey. Two. So I left off at 2 to the 3, which is 8, but I only have 2 remaining. So then what happens at 2 to the 2 must be multiplied by 0 because I don't have a 4 to fill. 0 times 2 to the 2. I still have this 2 to break down. And so now I have 1 times 2 to the 1. And then technically, I've used up all my empties. And so 0 times 2 to the power of 0. This becomes 1, 0, 1, 0, 1, 0, base 2. So 42 base 10 is going to be 1, 0, 1, 0, 1, 0, base 2. Yeah. No, you can do it your own way. This is always going to work, but a lot of other things do too, so that's totally fine. Yeah, like I said, sometimes if once you get used to doing this stuff, you'll move away from this method, right? But it's nice to kind of have okay, now I do this and now I do this. But you guys are going to be so quick at this later. Okay. That was one of the ways. Let me count the ways. How can I'll do it here. The second way would be repeated division, which is a little bit, well, kind of fun, kind of not, I guess. I'll write it down here. Repeated division, which is probably how I prefer to do it, because then what can I do? I can just start dividing by whatever my base is that I want. In this case, I want to move to base 2, right? The only tricky part is I tend to write it from the bottom up, and then so it can be kind of difficult to judge how far down you should start. I'll show you. So if we're starting with 42 base 10, and I want to move to base 2, desired base, all right, is this guy right here. You can use your calculator. 42 divided by 2 puts you at 21. And you're going to want to keep track of your remainders because the remainders will make up the binary digit, the binary number. And so 21, repeated division, we do just that. You keep dividing into 21. So 2 goes into 21 10 times with the remainder of 1. And you keep going until you're done, until you run out. So 2 goes into 10 5 times with the remainder of 0. 2 goes into 5 2 times with the remainder of 1. 2 goes into 2 1 time with the remainder of 0. Kind of becomes this leaning tower of Pisa here. 2 goes into 1 0 times, but then there is a remainder of 1. And then what happens is we read this down. One zero 1 0 1 0 base 2. Are you guys familiar with the therefore sign yet? Yeah. Therefore, 3 dots. They're usually nicer looking than that. Therefore, 42 base 10 is 1 0 1 0 1 0 base 2. Again. I'll add the next one to the list of questions that you can do at the end of class or on your own if you like. But I also want to, is this one I want to bring in the calculator, and how can I do that? Do I even remember how? Let me try. And let me just play around with it. Okay, I think I did it. Okay, how do I only know this because my students taught me last year. So here we go. I'm gonna add a page here maybe. Oh, if I can. I can. Okay. Where's that beauty picture of my calculator? There. Crop top this. Okay. So if you have, like I said last day, if you have these oh, that doesn't show up, does it? If you have kind of buttons like this, you can move between these bases relatively easily. Yeah. And so I had to do quick refresher. On this calculator, so it's worth reading your manual or watching a video or something. But what I'm going to do is I'm going to show you how it works, and then I'll do little snippets. Can you guys see this? Not exactly the ASMR situation you're used to, is it? Well, maybe it is. I don't know. But on mine, I have to change in the menu. Can I see here? So I have to go menu, and then I've got 2, 8, 10, and 16. So base 2, octal, decimal, and hexadecimal. So if I hit, I guess okay, probably. But if I hit 3, it'll just go into that menu option. So it might be something similar, because notice that my buttons are blue and I don't have a blue button to get to those. And so that's how I get there. Okay. And so what I'm going to do is I'm going to enter my decimal number 42. Okay. And then what am I going to do? Maybe hit equals, may or may not be necessary. I'm not sure. I have to play around with it. And then what do I want to do? I want to move to binary. 42 in binary, it starts off, it's got all these places for zeros, but then we start here, 1 0, 1 0, 1 0. Neat. Just did that twice, 2 different ways, but this feels a lot easier. Yeah. What about octal? 42 in octal is 52. Hexadecimal, 2A. Uh-oh. So you can move between these. And of course, you should be able to, I think that's why it has the A, B, C, D, E, F is for the hexadecimal on here. So that's how many we need past 10, right? Or 9, I guess. And so play around with that. You'll be able to enter into the different categories. I'm going to put this down because it's hard. But now, okay, on my calculator, let me remove that for a little bit. So on mine, to convert between base 2, 8, 10, and 16, between bases 2, 8, 10, 16, on this calculator, you have to change the menu and you have to hit, I have hit 3. Yeah. Then press whichever button you want to enter. And enter the value that you want to start with. So for example, we were in decimal, so I did in enter 42. And then I hit the equal sign. I'm not sure. I feel like it needs to kind of know to store it and keep it, but maybe I'm old. Maybe it just knows. And then your instruction manuals for your calculators are gonna do a way better job explaining it. This is just me. And then press this, and press this. Then press the base you want to convert to. Whee! And then I'll just give it to you. Lots of options. Any questions about that? Oh yeah, I'll try to recreate the magic. It was in menu setup 3, which kind of looked like 2, 8, 10, 16, kind of like a matrix like that. Was the menu option. Wait. Or using your calculator. On the next page, just to explain what's happening there. Third option. Hey, base 3 isn't on the calculator. Aha, I know. So you have to do one of the hard ways. So you have to know still. How are you going to do it? I prefer repeated division, but you also have the base 3 table, right? Keep going, place it. They're basically the same thing. I have a hard time saying that one is extremely different from the other, but whatever. Probably know binary is a way to communicate with computers through on-off switches, right? And so of course, 0 is off and 1 is on, right? And so, tick, 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 right? This on, this off, this on, this off makes an A, right? This on, this off, this on, this off makes a B, blah, 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 right? So it's all these switches. And so that's why we need to be able to move between the bases. So if we have to change base change 1, 1, 1, 0 base 2 to base 10. Remember how to do that? A little refresher, right? Because the only kind of trick that we have so far really is to move into base 10, you're going to write it in expanded notation, right? And that's going to be the easiest way to do it. Okay. Of course, you can check it with your calculator, right? Because 2's on there and 10 is on there, jackpot, right? Of course, on the test, I'll have some of those, right, that are obviously on the calculator, but I'll also have a couple mixed in there where you have to write out what you're doing, right, in one way or another. Just expanded notation is fine, or expanded form is fine. But what would that look like? Let's pretend we don't have our calculator for a second here. Then I'm gonna write out 1, 1, 1, 0. Right. I like to do my slots. This is in base 2, so underneath I have 2 to the 0, 2 to the 1, 2 to the 2, and 2 to the 3. expanded notation. This is going to be 1 times 2 to the 3 plus 1 times 2 to the 2 plus 1 times 2 to the 1 plus 0 times 2 to the 0. Which is 8 plus 4 plus 2 plus 0, putting me at 14. Squeeze it in there on the same page. Slave to these page breaks. Oh. Okay. Nice. Do I dare try it on my calculator under pressure? Look at me go. Well, maybe not. Let's see here. Turn it on. Okay, so I'm already in the menu and I want to enter a binary 1110, right? I'll let it keep it. And then I want to move into base 10. Hey, did it. So shaky. There's got to be a better way to do this. There is, but I have a lot of calculator apps, but I don't have that particular one. Got the business math one. I've got Desmos, but to hunt it down. Or do I? It's been a while. I'll find out. Okay. Do you remember how to change from base 10 into a different base? How do we do that? I'm going to go for long division. I know it's not the crowd favorite, but it's my favorite, and I get to do it however I want, and you get to do it however you want, as long as we land on the same thing. I'll write out my way, and you can work on your way, and we can just make sure that we get the same thing. Let's see here. No, I'll keep it zoomed in here. Gonna need a calculator. Oops. Did you get, however you got there, using the calculator, I don't care. 1 0 1 1 1 1 base 2. Cool. Each of these switches is called a bit, binary digit. One or zero. Is that true? I feel like there's like, I don't know. I'm having a flashback to something that I meant to fix in here, but that's okay. Oh yeah. Let's just skip ahead because I don't like that feeling. But what does this mean? On, off, on, on. All right. And what does it mean? Well, ASCII, I think it's called ASCII. I feel like I just have heard it, and that's what I just call it. American Standard Code for Information Interchange is kind of commonly used. And so we've got these ASCII codes. 32 generates a space, for example, right? Because we have not just numbers that we need to communicate. That would be great, right? But we also like to type letters, for example, right? And so we need some sort of code for that. And so we've got these ASCII codes, and of course, lowercase letters are different from uppercase letters, right? Can't just be going out willy-nilly. So if you want to write the word cat in ASCII code, although I feel like code is redundant. Yeah. No, I won't. It'll be more for assignments where you would have access to it. I don't see a need to be kind of printing it off only to test this. But yeah, otherwise, yes, I would absolutely have to do that. Don't worry. You can just memorize it, right? No. Jokes. Okay, so the table is a little bit confusing to read because the symbol is to the right of the ASCII code, whereas usually we're looking up the symbol, but then we want the ASCII code. So usually we would read it the other way around, just as a heads up. But we can handle it. This is all lowercase, right? Notice that's one thing to keep in mind, right? We've got uppercase, lowercase letters, they should be different, right? And so lowercase c is just off the charts here. That's why I can't have it on a test, for example, right? I could give you the relevant symbols and ASCII codes on an assignment and make you work through it, but not on a test because it's way too much. But C is going to be 99, right? If a lowercase a is 97, lowercase b is 98, logic dictates lowercase c is going to be 99. We have a on there. A is 97. And I'll tell you that T is 116. And we can convert this to binary, right? 99, we can convert it to binary. You can go ahead and do it with your long division or with your calculator, but I'll just tell you, I've started with a 0 in all of these, and I know the reason, but you can ignore it if you want, I guess. 0, 1, 1, 0, 0, 0, 1, 1 is 99. How can you confirm? Could write this out in expanded notation, right? 1 times 2 to the power of 0 plus 1 times 2 to the power of 1, blah, 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 right? Add them up and you should get 99. Assuming I wrote down the right number of zeros, 1, 2, 3, 4, or 3, yeah. 97, 0, 1, 1, 1, 2, 3, 4 zeros. Zero, one, and 116, 0, 1, 1, 0, 1, 0, 0. All these years of teaching, I'm still waiting for someone to auto-tune me, just reading out digits. I think it would be pretty cool. Maybe I should take it on. But also, maybe I don't care that much. Catchy. Right? In terms of, oh, that's why I have a 0. Why? Groups of 8. That's why. Makes a byte. So a byte here is off, on, off, etc. In this course, all we care about is being able to move between the bases, right? And so far, right, we know how to move from base 10 into another base, right? Long division usually, or whatever fancy mechanism you have. And we can move from any base into base 10 by expanded notation, right? Or expanded form, and just doing the math, right? Those are the 2 skills that we have so far. Is that right? Time flies when you're having fun, huh? It is correct. Okay. One time I was teaching a summer course, and it was in stats, and I can talk about stats forever. And it was a 3.5-hour course, or a block, and I just talked the entire time, and I forgot to give them a break. I know, rude. Okay, I think because I probably should have given you a break, we only just started classes, we'll call it there. And for this week, because we're still kind of figuring out our schedules and stuff, I'll be here on Friday. Brutal. And we'll keep going through with binary arithmetic. And so make sure you complete those examples on your own, or stick around, you can do them here. And with that, I release you. See you on Friday.